Rapleaf, and I'm one of the engineers on our analysis team there. And today I'm going to talk a little bit about the system we use to push our code from Subversion repositories into production. Rapleaf is a data technology company. We work with demographic and sociographic information about consumers to help other companies treat their customers as individuals. I program jointly in Ruby and Java, depending on the projects that I'm working on any given day. And Ruby's my favorite of the two. It's so much easier to work with. Ruby's a great place to start. Every language is better when there are other people for you to talk with. And when you have the opportunity to say, I think this is a really good way to do this, what do you think? To someone who's sitting next to you, you learn a lot faster. Really strong companies' goals are to take as much of the repetitive work out of something that the programmers are doing every hour and push it into automated tools. What we want is to make sure that it's really easy for people to deploy new code to production, but also make it hard to deploy old code and make it hard to deploy only to some machines or leave machines in a bad state. We also want to make sure that the process of taking machines in and out of a load balancer so that we can do a rolling, no downtime deploy. The things we were focusing on is making sure that we can handle when a lot of people want to deploy, so we don't deploy on top of each other, and nicely handling the case that we add a lot of new projects, and so we want it to be easy to set up and deploy. We spend a lot of time at the office sharing information and then explicitly putting together presentations to help each other learn better practices for the various languages and tools we use.
I'd like to introduce Emily Leathers, who is from Rapleaf. We're going to talk about how Rapleaf does deployments.
This is now deploying a Rails app. This one's really simple. It's an internal thing, and it's just going to deploy to a single server. But you should also be able to see, if I did this right, that this is my ADM window, and it's a chat room that we have on Jabber. And it says right here that we started deploying this project and finished deploying this project. So if you want, you can just sit all day in this chat room and let the notifications of people deploying roll in. It also tells you every time someone commits. And we also have in our admin site, let's see if I can find my mouse, this deploy history page, which will show you all the projects, when they were deployed, what command was used, who did it, and then if you click over to the right, you should also be able to see which commits went out. This just helps us debug. If something went really wrong because someone deployed at midnight last night, we can track down what changes went out. Or if you're an intern and you don't have deploy permissions yet and you're waiting for your mentor to deploy, instead of pinging them every 10 seconds to ask, you can just reload this page. So, all right. So what requirements did we have for our system? We kind of had three sets. One's from the user. We needed something that would work with both Ruby and Java because we work in both and we didn't want to have to use separate systems. We want to be able to add deploys for new projects. We probably add new projects that need deploy once or twice a month. So if it was a big pain for it to set up, our ops team would be pretty annoyed at us. We need to be able to specify when a machine isn't working anymore. By the time you reach the couple hundred machines that we have, they lose hard drives a lot. Sometimes other things go wrong. You know, something's faulty. You need to be able to not deploy to it. And because we use Java and we use Hadoop and we run long-running Hadoop jobs, sometimes a couple days at a time, we need to make sure that if I deploy a project, it can't mess up a job that I'm already running or that someone else is already running. Finally, multiple people need to be able to log into the deploy system. And it should be really easy to use. You shouldn't have to jump through hoops. So from the point of view of our ops team, they only want us to be able to deploy each project one at a time. So I can't deploy a revision of admin while you deploy a revision of admin that's one later. The servers are going to get confused. It should have to wait. Like the tools we just showed a minute ago, there should be an audit trail. You should know who deployed what when. This is for a couple reasons. One, it helps you track down bugs and problems. Second, we work in a company where we work with consumer data, and privacy is a huge concern for us. So as part of dealing with that type of data, we always need to know who's touched every file and who's changed every possible external service at any given point. And finally, you need to be able to disable deploys. You need to be able to say, I know this project is broken, please don't do anything, or I'm changing something that will break all of our Java projects. If you deploy them, nothing will work anymore. And then we needed something that was fast to build and didn't introduce any new dependencies. So there are a lot of really great deploy systems and build systems out there, but we needed something that we could do really fast and that looked a lot like what we already had. So what we used was a combination of Screen, Capistrano, and Subversion. Screen allows multiplexed windows, so in our case they're shell sessions, and you can attach to a virtual terminal. So it stays there even when I log out, and 4 other people can connect, and it's kind of fun. You can all type at the same time. If you're not familiar with Screen, it's an amazing tool. You can also play practical jokes on other people, because as you notice, when I typed in my password, it didn't show up on the screen. If someone else was sitting there, they can just keep typing letters in the middle of my password, and I'll never be able to deploy. Could also be a bug in the system for us, but it works for now. So this means that we can coordinate between a large number of developers. We used to, maybe a couple of years ago, just deploy from your local checkout of a project. And that worked when you had 8 developers who sat back to back in a room and could turn around and say, I'm deploying Spider. Doesn't work quite as well when some of them go on vacation or live in Philadelphia, or you just have a room too big to shout across. Capistrano is a pretty popular tool. Pretty much it allows you to issue the same command to a lot of machines at once, or to take a whole bunch of machines, cut them into groups, and issue the same command to each of those a group at a time. We use Subversion. We're not tied to it. You can pretty much use any version control system you want, but we end up using Subversion. And Pentagon is what we decided to call the system that ties all these together. So from a user's point of view, you kind of saw a short demo of it. You can type in deploy, you get there, and then the command that I pressed up enter for was please deploy, and then rev equals the revision number that I wanted. You'll notice I didn't have to type in the project name or any SVN URLs or anything else. It's because this deploy window was just for that project, and it already knew that information. Likewise, please is a kind of unusual command. We have defined please as SU to the specific user, and then run a cap command that was, in this case, deploy, so that second one. So why do we do that instead of just typing cap deploy? It's for a couple reasons. Because everyone's connecting to the screen. When you join a screen, you're in essence executing things as the user that screen is. And in this case, because we need that audit trail, we actually want users to execute the deploy as themselves. It's kind of roundabout. You're logged in as yourself. You joined the screen, and then for some reason, you have to give it your username and password again. It's not perfect. We would love to find a way around that. We don't know one right now. So that's part of why we use please. We also use please because you can type dammit instead, and sometimes that's really satisfying. So as said a minute ago, we keep history in the screen. You can just press up enter until the screen is restarted. It's all right there. You can check what was last deployed because it'll be there, and you can't deploy on top of each other because you'll see someone else typing. We also do keep all of this history in a database. That's what powers that web view you saw a minute ago. And to a Java server. So this is tied into our load balancer. The deploy scripts themselves know how to take machines in and out of the load balancer. So they'll choose a group of machines, pull them out, and then deploy to them and put back in. And finally, this little screenshot down here says you can't deploy. Any user can lock or unlock a deploy. You don't have to be the user who locked it in order to unlock it. Again, we're 25 people. It works fine for us. It might not work well if you were at a bigger organization. So we added in a couple of things to help protect against mistakes. One of them is that when we start this bash shell, we use -- restricted. Restricted means that you can't CD, I think you can't unset any environments, and you can't invoke a whole bunch of commands. We also override path and specify what bin commands people can use. This is pretty much just so people don't forget they're in the deploy and start screwing around with other things. We also alias exit so that it doesn't exit. That would be really inconvenient for us here, and a lot of people have a habit of, I'm done with what I'm doing, let's type exit. Here we want you to detach from the screen. If you do exit, it mucks things up for everybody else. And finally, our cap files do some checking so that you can't deploy old revisions. We wouldn't want to deploy 125 revision of the website and then have someone try to deploy 123. So you can do that, but you have to give a special override command. Sorry, let's see, where am I going? We keep all of our deploy information in structured directories in Subversion. So it's the Subversion, the deploys project, and then the project name is actually the SVN project name of the project that this deploy is for. And then we have a cap file for each of them. That cap file contains things like what commands should actually be executed when I type deploy. So that's going to be things like, first you should check out all the current source code at the revision you specified for this project. Then you should make a jar out of it. Then you should push that to these machines. Then you should run the restart command for those machines. And then we have shared information as well. So the most important is we need to be able to say, this machine isn't working, no deploy should try to access it. One of the reasons you want to keep that in a central place is we have machines that run multiple projects on them, and you don't want the ops team member who decommissions a machine to have to track down all out of the possible 30-something projects that this could affect. You want there to be one space that you put it in or take it out of, and you're good. It's kind of looking at how this stuff uses bash. There's a configuration here, and then this is kind of how it starts up. So you may want at some point to be able to change the way you deploy a given project. That's really easy. You change the cap file in the directory we mentioned a minute ago. You check your changes into Subversion, and then within the deploy screens, there's actually a screen for Pentagon, which is this project. And if you run that, it will update itself. It runs an SVN up. It replaces all the code underneath it. And the next time anyone deploys any of the other projects, it will just pick up the new code. It won't affect any currently running deploys. And you can also add and remove screens by, again, editing a file, restarting, and then restarting the deploy screen. Restarting the deploy screen has a couple extra features to it. We don't want to shut down any deploys that are currently running. You don't want people to start new ones, but you do want to wait for other ones to finish. So because of the way screen works, there's this kind of cool trick where you can get the process IDs of all of the little screen windows, and then you can get all of their child process IDs, and those are actually your deploys, and you just wait until there aren't any of those. So looking at the original requirements we had, this is pretty language independent. It's easy to add new deploys and specify machines that you shouldn't work on. The one thing I didn't touch on is how we deal with, in essence, versioning our deploys so that I can run off a version from 2 or 3 days ago, and if you deploy now, that version will still be there for me. So the way we handle this is that on the machines that we deploy to a directory for the project, but then a time-stamped directory underneath it. And there's a symlink called current that just points to the one that was most recently deployed. This also keeps us from running into trouble where we have to push new code, but we may still have a server running on that machine. So it doesn't cut over until you move the symlink, and then it kind of cuts cleanly from one version to the next. You can CD into the old directories. There's some scripts that go and clean up deploy versions that we don't need anymore. Otherwise, You don't want your last 100 days of deploy directories sitting around. It's going to take a lot of space. And it's smart enough to not clean up ones that still have any links pointing in at them from processes that may be using them. We learned that the hard way when things stopped working. Cool. So, of course, using screen, this works really well with multi-user. You can only have one active deploy because you only have one screen, and you don't get a command prompt back until the deploy finishes. And that locking enables you to disable deploys. We actually had most of the pieces of the system already in place. We were already using screens. They just didn't have a lot of the nice aspects added in, and we were already using Capistrano. So really what we did was build a framework to tie that stuff back together, which meant that it was fast, and it really didn't introduce much that was new. So things that maybe aren't quite as good as they could be right now. One of them is that we use Hudson as our build system, but this doesn't tie into that at all. So users actually have to check whether the Hudson build passed manually, and there's no restriction against deploying if the build is failing. It works. Sometimes we end up in kind of awkward places as a result of someone not checking right now, but it usually does what we need it to. It'd be great if we could build that in automatically. And again, I had to type in my username and password. It'd be really nice if it at least knew my username and who I was. If you know how to do that, that would be great. Please let me know. We've looked around and we've not been able to figure that out. So, finally, here's my contact information. Feel free to get in touch if you have any questions about how we do this or anything else that I can help you with. Are there any questions?